In question 9, we're still solving trigonometric equations, but now we're solving for all solutions. We're not restricting it to an interval, although the process in general is extraordinarily similar. Let's look at part A. We have 2 cosine squared x minus 1. We want to solve for that cosine x first. So we get 2 cosine squared x equals 1. Cosine squared x equals 1/2. So cosine x equals plus or minus the square root of 1/2. This means that we have two equations here. We have that cosine x equals a positive 1/2, square root of 1/2, and cosine x equals negative square root of 1/2. For the positive square root of 1/2, it's the same as 1 over rad 2, which is the same if we rationalize that denominator of rad 2 over 2. For negative square root of 1/2, this is the same as negative 1 over rad 2, which is the same if we rationalize the denominator of rad 2 over 2. Let's solve for cosine x equals positive rad 2 over 2 first. We get x equals cosine inverse of rad 2 over 2, which means we're solving for all the angles where cosine would give us rad 2 over 2. Remember, cosine's our horizontal distance, it's our x value. So going around our circle, for our x's we see rad 2 over 2, and let's see rad 2 over 2 for our x coordinates. Thus, the values for x are pi fourths or 7 pi fourths. Okay, now let's look at cosine x equals a negative rad 2 over 2. Since it's negative, this occurs at 3 pi fourths and 5 pi fourths. So get x equals cosine inverse of negative rad 2 over 2. X equals 3 pi fourths and 5 pi fourths. Recall though, we want to find all the solutions, not just the solutions from 0 to 2 pi. The way we write this is that x is a set of solutions, pi fourths times n, 7 pi fourths times n, or sorry, that was my fault, is a set of solutions of pi fourths plus as many full rotations as we want, so plus 2 pi n, 7 pi fourths plus 2 pi n, 3 pi fourths plus 2 pi n, and 5 pi fourths plus 2 pi n, such that n is an integer. So we could take any of these four angles and we could go straight to pi fourths, or we could go full rotation and then to pi fourths, which would be the same as pi fourths plus 2 pi. Okay, let's look at part B.